Okay, so let's finish up our discussion of quadratics, in particular, our discussion of the discriminant using the quadratic formula. So we have the quadratic formula here, and we know that the discriminant is b squared minus 4ac. And that gives us either a negative number for the discriminant, a 0 for the discriminant, or a positive number. And a negative number in the discriminant means no solutions if we were back in Algebra 1. But in our case, we're in Algebra 2, so we say it's no real solutions. However, I have two complex or imaginary solutions, also known as roots. Now, you also have 0. If you got 0 for the discriminant, that means that you do have real solutions, but you're only going to have one real solution. We'll talk about that in a second. Finally, with the discriminant, you could have a positive number, and you're going to have two real solutions and no imaginary solutions or no complex solutions. But we could have two types of real solutions. We could have rational or irrational. Now, by the way, the difference between rational and irrational is irrational has square roots left in them, things like square root of 3. So, with that in mind, we not only need to know the number, we need to know the type of solutions, and we're also going to talk about this idea of matching. Do they match or not? With that in mind, let's take a look at our first example. Our first example is x squared plus 3x plus 4. So obviously a is 1 because we have the understood 1 as the leading coefficient. B is 3, C is 4. We plug it in. We say, oh, look, underneath the square root, the discriminant is negative 7. So I have negative for the discriminant, no real solutions, two complex solutions. So we can't say no solutions, just no real solutions. So if we bring this down here, let's finish this up. How do I break up a fraction that is over a single number? Well, what I can do is I can split the denominators such that they have common denominators, and they're over their own denominator each piece. Now you'll also notice the square root of negative 7 can be rewritten with imaginary numbers and say I root 7. Now I prefer to put the I out front, but delta math may require that you put the I all the way to the back. But if you're typing it in delta math, it's going to be much more clear. There's no chance of you getting it confused. But if you're writing it by hand, I recommend putting the I up front. So in this case, we have two solutions because we have negative 3 halves plus root 7 over 2i. That's 1. And we have negative 3 halves minus square root of 7 over 2i. Those are the two solutions, but they are two non-matching imaginary solutions. Two non-matching imaginary solutions. The other thing to remember is anytime we talked about polynomials, if we had a positive as the leading coefficient, it means it's going to be standing in the normal direction. So since all quadratics are parabolas, positive means we're going to be opening up, versus if we had a negative, we would be opening down. So those are important pieces of information because we don't even need the equation to know what type of solutions we have. Let's go ahead and quickly move to this. In this case right here, if all I do is give you graphs, you can tell me what types of solutions each of these has and tell me about this graph. Now, you'll also notice that we had this discussion in our last video where we had a real solution that was just simply two of the same. So keep that in mind as we go through here. In this case, any place it crosses the x-axis, that means it is a real solution or root. So any place it crosses the x-axis, it's a real solution root. So in this case, you would say, oh, I have two real solutions. Now, because they're in two different places, we would say non-matching because they're not exactly the same. And so there we go, two real non-matching solutions. Over here, we have exactly 0 real solutions. And so if we have 0 real, automatically we have 2 imaginary. In this case, it's going up. We have 2, and they are 2 real solutions, and they are not matching, non-matching. The other thing that we have going on, though, is we have this guy. This guy looks a whole lot like this equation right here, and it comes when we have something that would be x plus 2 times x plus 2, so something that was x squared plus 4x plus 4, if that's what y equals. It breaks down into 2 factors, but when I solve it, x equals -2 happens twice. So you get 1 real matching, because they are literally the same, solutions. They're 1 real matching solution. So technically, I believe Delta Math says, no, there are 2. Those 2 just happen to match. So that's an important thing, looking just at the graphs. Alternatively, if I have something like this, if I have y equals x squared plus 2x plus k, I could determine, how do I get complex, single, or real solutions? And the way to do that is simply to get the discriminant, b squared minus 4ac, so in our case 2 minus 4, so 2 squared minus 4 times 1 times k. And we know that it's complex if it is less than 0. We know that we could get exactly 1 solution, or 2 matching real solutions, if 2 squared minus 4 times 1 times k equals 0. Or if I wanted 2 real solutions, I would simply say 2 squared minus 4 times 1 times k has to be greater than 0. At this point, all I have to do is begin solving. 4 minus 4k is less than 0, minus 4, negative 4k equals is less than 4, negative 4. Divide both sides by negative 4. Now, of course, remember, when you divide by a negative, you must switch the sign. And so if I have any k value bigger than 1, it's too complex. If, on the other hand, I have the exact same thing, but now I have equals 0, negative 4k equals negative 4, k equals negative 1, would make 1 real or 2 matching real. And finally, 4 minus 4k is greater than 0. K would be less than 1, would give us 2 real solutions, non-matching. All right, so that should help you. That should help you get your Delta Math done as well. So with that in mind, that's a long video, but that's okay. It's still only